Hekk kif tiżdied il-pressjoni fuq id-ditti tal-karozzi biex jipproduċu vetturi b'inqas emissjonijiet, allura dawn id-ditti stess dejjem jistudjaw teknoloġiji ġodda. Aħna ġejna l-Ingilterra tapposta għand it-Toyota Technical Center fej ħansuqu l-ewwel production vehicle li hija fuel cell taħdem bl-idroġenu. Miegħi għandi Neil Spires li huwa l-Product Manager tal-Mirai u miegħu ħanippruvaw nifhmu eżattament din it-teknoloġija fiex tikkonsisti. Neil, the pressure on the automotive industry to come up with new technologies with lower emissions produces something like the Mirai, a new concept. Maybe you can give me a bit of detail about this model.
Yeah, sure. I mean, we've developed and moved forward with hybrid technology for a good number of years now, but equally we're aware that the next step needs to be made, and zero-emission mobility is a key objective for the company and the industry as a whole. So hydrogen fuel cell really can deliver that. We get zero emission, water out the back of the car, and ultimately that achieves that objective to clean up the air quality around us and hopefully move towards an improved climate change piece for the world we live in. So this is a really positive step for Toyota.
You sort of eliminated the electric mobility step, which most of your competitors are going to, but you still have research and development going on with electric cars.
Absolutely. I mean, we have plug-in vehicles ourselves and hybrid vehicles, but equally we believe there's a place for EV technology. At the moment, with battery constraints and range constraints, we feel that's more in personal mobility and shorter distances. And therefore, we're not stopping our development around EV technology, but we feel that's where the place is currently within the technology parameters.
Can you give us an outline on how the fuel cell technology works?
Absolutely. So in essence, you've got a fuel cell stack that sits within the car, and you pull in hydrogen from the fuel tanks and air, and in essence you get a chemical reaction going on. The hydrogen is broken out, you release electrons, you create an electric charge, ultimately 370 times within the Mirai fuel cell stack, and that gets ramped up to 650 volts to drive the car. So it's a mini chemical reaction, and then the output is just water out the back.
What about the fuel itself, the hydrogen?
Yeah, the hydrogen, it's an interesting one. It's a very abundant fuel that's produced in millions of tonnes every year currently. Yes, there's a fuel that needs to be put in the car via infrastructure, and that's something that we're looking to develop over time. But it will go into 2 tanks within the car as far as the Mirai infrastructure, and that's kept under high pressure and then is fed into the fuel cell stack to create that chemical reaction.
What capacity of hydrogen can the car carry and how much autonomy will that give you?
Yeah, I mean, the benefit of a fuel cell car is that it's very quick refuel time. So you're actually putting in 5 kilos of hydrogen to fill the Mirai up fully. To put it in perspective, that's around 120 litres within the tank, but we measure it in kilograms. The fueling time is about 3 to 5 minutes, so very much the conventional refueling time that everyone's familiar with today with a normal car that they'll be driving today.
Obviously, there's the infrastructural problem. At the moment, how many fueling stations are there in the UK?
So fueling stations in the UK, we're around 3 to 4 at the moment, with probably another 4 to 5 opening this year. So very small at the moment, very much based around London presently. So it's small steps as we encourage fuel cell cars coming through. We get infrastructure building, and then we can go hand in hand and actually build that together.
When you came to design the first hydrogen-powered car, what considerations did you put into it?
I think the key thing was the customer experience. We needed not only a good range, quick refueling time, which was that convenience piece, but equally comfort and obviously the experience of a quality car that was provided. So that was really the core piece. With Mirai, one of the challenges of R&D is actually to build it in a saloon car configuration. So if you can do it in that configuration, you can build it in any configuration. And therefore, the challenge that the Toyota engineers set themselves was to produce the first generation as a saloon. And this is what we have today.
Is the driving experience any different to, say, a normal hybrid?
In essence, no. The principle of the hybrid drive is there with Mirai. It is a hybrid. Obviously, you don't have the gasoline, petrol engine in the vehicle, as we'd see in our traditional hybrids today. So the actual driving and mechanism of using the car is exactly the same. Yes, there's a different experience as far as the electric aspect of the drive as you're going along, and some slightly different noises with the fuel cell stack in operation. But in essence, to drive it, it's very much the same.
A question that just came to mind, I haven't discussed it before, I hope I won't surprise you, but what is the cost of hydrogen?
Hydrogen in UK is around 10 to 15 pounds, so that would be maybe 15, 16 euros a kilo. So it's measured obviously in kilograms, as we spoke about, but it's around £50 to fill up a Mirai, which is very comparable to a conventional car.
What about maintenance on the car?
Maintenance is very good with a Mirai. You don't have to maintain a petrol engine for starters, so there's no traditional checks that we'd be familiar with today on a car. So it's very light on maintenance. Yes, you need to do the relevant checks for operational aspects of the fuel cell stack, the hydrogen components, make sure that there are no leaks, standard checks that we'd do on a petrol car today, and equally standard maintenance pieces of tyres, washer fluids, etc., coolant fluids. So, but very comparable and very cost effective.
Vital statistics in terms of performance?
Yeah, top line statistics, the output of the system is 154 horsepower. 0 to 100 kilometers is 9.6 seconds, and you've got 335 newton meters of torque. So very immediate torque in the fact that it's electric drive straight off. So quite a positive experience, very immediate response and acceleration.
What about the safety issue? People might have a preoccupation about carrying high pressure hydrogen in the vehicle.
Yeah, the tanks that are an integral part of the car are built to a very high standard. They're built to withstand very high pressure, impact tests, so they're built and regulated to a high level by Toyota and the relevant bodies that govern that. Within the car there's numerous sensors and safety measures to protect the car and the occupants, to give suitable warnings if there is a hydrogen leak, in essence. So there's a whole host of safety features to protect the customer and the driver alike.
What about numbers? How many have been produced so far, and what are the forecasts?
Globally, so far, 2015 was the launch for Mirai, and 700 units were produced globally. 2016, we're at 2,000 units, and it goes up to 3,000 in 2017. Within Europe, there's smaller numbers, really to reflect the infrastructure and where it's at the moment. So in the UK, we're going to be selling around 15 a year approximately, to reflect where infrastructure is, and we'll move it on suitably when infrastructure expands accordingly within the locations.